All right, this is the help on the study island topic, binomial theorem. So again, whenever you do one of these topics, you should probably have the lesson tab open next to you so you can look at it as a guide. Here's the binomial theorem lesson tab. Lesson open a new tab. The binomial theorem is a method for expanding binomial expressions that are raised to large powers. The binomial theorem is given by the following formula, and then blah, you've got this formula here. Let's walk you through from the beginning exactly what we're looking at. First, what is a binomial? A binomial is just two terms. So if I have a plus b, that's a binomial. If I have x plus y, if I have 3x plus 7, that's a binomial. X plus y is a binomial. Anytime you have two separate terms like that, they are binomials. So let's take a simple binomial like a times b, and let's multiply it by itself once. Let's square it. If you have a plus b squared, what that turns out to be is a plus b times a plus b. So let's write that out for a moment. We've got a plus b squared, so that's a plus b times a plus b. Well, if I'm multiplying one binomial by another, I'm multiplying each term in the first binomial by each term in the other binomial. In other words, I have to do a times b, then I have to do b times a, and b times b. So what does that look like when we multiply it out? A times a is a squared, a times b is ab, b times a is the same as ab, so plus another ab, and b times b is b squared, so plus b squared. Well, ab plus ab is 2ab, so I have a squared plus 2 times a times b plus b squared. So if I said a plus b squared, this is what I get. Well, what if I said a plus b to the third power? A plus b to the third power, not a plus 3. A plus b to the third power. Well, you should recognize that anything to the third power is the same as that thing squared times itself. So I'm just going to take this, a plus b squared, and I'm going to multiply that by a plus b to get this now. So something in this, which is this polynomial is a trinomial. It's not a binomial with two terms. It's a trinomial. It's got 3. But if I multiply this polynomial times this one, this trinomial times this binomial, I multiply each term in one polynomial by each term in the other. So I've got a squared times a, which is a cubed, a squared times b, which is just a squared times b. There's no other way to write that. And now I have 2ab times a, so I'm going to say plus 2. A times a is a squared, and then I have b, so that just stays there. So again, 2ab times a is 2a squared b. And now I have 2ab times b, which is 2 times a times b, so 2 times a times b squared. And then I have b squared times a, so that's plus a times b squared. And then I have plus b squared times b, which is b to the third power. So what combines together here? Well, a third is just by itself, so I have a to the third power. But a squared b plus 2a squared b is 3a squared b. And then I have 2ab squared plus 1ab squared is plus 3ab squared. And then I have plus b cubed at the end of it. So this would all be a plus b cubed, this whole thing. Well, what if I had a plus b to the fourth power? A plus b to the fourth power would just be this whole thing, which is a plus b cubed, times a plus b. Okay, so we have a plus b cubed times a plus b, so that's a plus b to the fourth power. Again, let's multiply everything in this polynomial times this polynomial. So here we go. A cubed times a is a to the fourth. A cubed times b is plus a cubed b. And then we have 3a squared b times a, so 3 times a squared times a is 3a cubed b. And now I have 3a squared b times b, which is plus 3a squared b squared. And now I have 3ab squared times a, which is plus 3. And then a times a is a squared, and we still have b squared. And then we have 3ab squared times b, which would be plus 3ab cubed. And then after 3ab squared times b, we have b cubed times a, which is ab cubed. And then we have b cubed times b, which is b to the fourth. So what does all that end up looking like? And trust me, there's a point to this, so just bear with me. A to the fourth power is just a to the fourth power. A cubed b plus 3a cubed b is 4a cubed b. So plus 4a cubed b. So that's this term and this term. Plus we have 3a squared b squared plus another 3a squared b squared. So that's plus 6a squared b squared. So that's these ones put together. And then we have 3ab cubed plus ab cubed is 4ab cubed. And then lastly, we have plus b to the fourth power. So hopefully what you're seeing here is you're start to seeing a pattern develop. Here, a squared, b squared, in the middle, 2ab. There's some symmetry. Then after that, we get a cubed, b cubed, and 3a squared, 3ab squared in the middle. Again, there's some symmetry there. And then here we get a to the fourth, b to the fourth. Terms inside are 4, and then a cubed b on the left and ab cubed on the right. And then in the middle, 6, a squared, b squared. So you'll notice that there's a pattern developing, and that pattern will help us. We don't have to keep multiplying these out the whole time. If we can just harness that pattern, then we can make predictions for really large numbers, and I don't have to multiply all this stuff out if I get numbers larger than 4, 5, 6, and all those. So let's take a look at what that pattern is. If you go over to these tabs for binomial theorem, you're going to find in tab 1, if you scroll down, Pascal's triangle. Look at Pascal's triangle. What is Pascal's triangle? Well, you start with 1 at the top. And then you have 1 in this first row. After that, each thing underneath is when you add the two numbers that tree kind of off of it together. So what is, if we keep going down the ones here, what is 1 plus 1? It's 2. And then what is 1 plus 2? It's 3. And 2 plus 1 is 3. And then what's 1 plus 3? 4. And what's 3 plus 3? 6. And what's 3 plus 3? Or 3 plus 1 again? 4. And you'll notice that these were the coefficients that we came up with. A squared is 1a squared. 1. Plus 2ab. 2. Plus 1b squared. 1. And then our very next one, which was this one, this was, remember, ab cubed, this set of parentheses right here, we started off with 1a cubed, so there's 1, plus 3a squared b, 3, plus 3ab squared, there's a 3 again, plus 1b cubed at the back. And then we have 1, 4, 6, 4, 1, and that's what we had right here, 1, 4, 6, 4, 1. So we can use Pascal's triangle to actually figure out what all these coefficients are, and that could keep going, but this one only goes up to 7. But we could keep going on and on and on forever. So if I asked you for a plus b to the 7th power, I know exactly how that's going to turn out because of Pascal's triangle, and I can look at the 8th row of the triangle because the top row is just this 1, it doesn't really count for anything. I can look at that triangle and I can figure it out. So when we have this bottom one right here, I know it's going to be 1 as my leading coefficient, and my leading term is going to be the first term in the binomial to the exponent we're raising it to. So I'm going to start with 1, a to the 7th. Now my next one, just like before, I'm going to take away 1 from that exponent, and I'm going to get the other one in there, the other term, but it's just going to be b, and this is to the first power. So I have a to the 7th plus, my next term right here is a 7, so that's going to be 7a to the 6th, b to the 1st, which I'll just write as b. And then next is 21, so it's going to be plus 21. And then again, I'm going to take away from the 6 and make it a to the 5th. But I'm going to add 1 to the b's exponent and make it b squared. And this is the pattern that these all follow. Minus 1 from the a exponent keeps going that way. And then my next one after 21 is 35. So I have 35. A to the 4th power, b cubed. And now we're just going along the other side with these exact same coefficients, but we're slowly changing the exponents one by one. So I've got plus 35 a to the third, b to the fourth, and then plus 21, a squared, b to the fifth, and then plus 7, a to the first, b to the sixth, and then last but not least, I have plus b to the seventh. Now, you might ask yourself, well, what happens to the a on the last one? After a to the first, it's a to the 0 power, a to the power of 0. And anything to the power of 0 equals 1. So we have just 1 times b to the 7th, and that's what we end up with. So that is how that pattern continues. You don't have to multiply it out every single time. Well, what does that mean? That means that we can identify exactly what term in each one of these has exactly which properties, and we can use these formulas to do so. So here we go. The binomial theorem is a method for expanding binomial expressions that are raised to large powers. The binomial theorem is given by the following formula. Recall the combinations formula, which produces the binomial coefficients, a combination of a set of n distinct objects taken R at a time without repetition is an R element subset of n objects. This is the combinations formula. If you haven't looked at the combinations yet, you should go ahead and do that. Practice the combinations formula because it's super helpful for the binomial theorem. It'll make it easy if you're practicing this. So go do the go do the combinations topic first if you haven't done that yet. All right, let's go ahead and do problem number 1. Okay, the easiest way to do this problem is a pretty simple process of elimination. So let's go ahead and take a look. X over 5 plus 4 over y to the 4th power. First things first, just like we looked at a second ago, every time you raise a binomial to a certain exponent, the expanded polynomial is going to have one more term than the number of the exponent. What do I mean? I mean that take a look at a plus b squared. When we did a plus b squared, which is a plus b times a plus b, we ended up with a simplified expression that had 3 terms. So it was raised to the 2nd power. We had 3 terms. Then we multiplied out a plus b to the 3rd power, exponent of 3. Our simplified expression had 4 terms, 1, 2, 3, 4. Similar thing with our to the 4th power. To the 4th power, we had 1, 2, 3, 4, 5 terms. So you're going to have 5 terms when you multiply a binomial to the 4th power. So that eliminates a right away. The next thing is everything's positive here. There's no negatives. It's the first term plus the second term. There's going to be nothing but positive numbers. No negative signs are ever going to come into this. So we're also automatically going to get rid of choice B here because there's negative signs in there. There's no reason that we need to subtract anything. So that leaves us with C or D as our final answer. They both start with x to the 4th power, which is good because you need your leading term raised to the exponent that the binomial is being raised to. So they both have x to the 4th. X over 5 to the 4th power is x to the 4th power, and then 5 to the 4th power is 625. But what's the next one going to be? That's where the first difference is. Is it 4x cubed over 125y or 16x cubed over 125y? Well, luckily, we just did something to the 4th power. We can see it's going to be 4 times the first term cubed times the second term. So what does that mean? Our first term in this binomial is x over 5. And our second term is 4 over y. We want 4 times the first term cubed times the second term. So what does that look like? Well, it's going to be 4 over 1 times x cubed over 5 cubed, which is 125, times 4 over y. So we have 4 times x cubed times 4, which is 16 x cubed, and we have 1 times 125 times y, which is 125y. So we have 16x cubed over 125y, which makes that the answer, and we can move on. All right, so now this one does have a minus symbol. So let's go through one thing at a time. First of all, nothing changes with the number of terms. If you have a binomial cubed, you're going to have 4 terms. So it's going to be this one or this one is our answer. There's no eliminating terms here just because of the subtraction symbol. So everything's going to have 4 terms. Next, what is it going to look like? If you have a minus b, let's go ahead and do that. If you have a minus b as your binomial, and you raise that to the second power, that would be equal to a minus b times a minus b. Well, what happens? We have a times a, which is a squared, and then we have a times negative b and negative b times a, so it's going to be minus 2ab. All right, we have two sets of negative a times b. The first one comes from a times negative b, which is negative ab, and the second one comes from negative b times a, which again is negative ab. So two sets of negative ab. Then we have a negative times a negative is a positive, so it's plus b squared. Well, a minus b cubed would be the same as a minus b squared times a minus b. So that's going to be the same as this whole thing. So a squared minus 2ab plus b squared times a minus b. And what does that equal? Well, you have a squared times a, which is a cubed. You have a squared times negative ab, which is negative a squared times b. You have negative 2ab times a, which is negative 2a squared b. This should all look very familiar because we just did this. Negative 2ab times negative b would be negative 2ab squared. And you have plus, negative 2ab times negative b is going to be plus 2ab squared because the negative times the negative is a positive. And then you have plus b squared times a, so plus ab squared. And then finally, b squared times negative b is negative b cubed. Why did we do all that over again with the negatives? Because you're going to see a pattern when you collect your like terms. You have a cubed minus a squared b minus 2a squared b is minus 3a squared b. And then you have plus 2a squared b plus plus 2ab squared plus ab squared is plus 3ab squared. And then you have your minus b cubed. Why am I showing that to you? It's absolutely no different than what we did before when we got this one, except for the signs. And this is a positive and a positive and a positive and a positive. This one, positive, negative, positive, negative. And that's all it is. If you have a difference in your binomial, if your binomial is subtracting two terms, and we raised that, I wrote that poorly. If you caught that, good. I wrote that funny. But if you have a subtraction in your binomial, and that's being raised to a power, all that happens is that your first term is positive, and then every term after that flips back and forth. First term's positive, next term's negative, then positive, then negative, then positive, then negative, then positive, then negative. That's the only thing that changes. So when we go back to this problem, what's the only one that fits that pattern? I don't even have to multiply this out if I want. I'm going to find one with four terms where the first term is positive and then it flips back and forth. This one, it's like the first term is positive and the rest are negative. That ain't it. So the first term is positive, then negative, then positive, then negative. That's our answer. Okay, next one. Expand the following expression. 2x plus 3y to the first power. Anything to the first power just stays the exact same, so it's 2x plus 3y. There's not a lot of thinking to be done there. Expand the following expression. 3x minus y to the third power. Okay, to the third power means we're going to have four terms. So we've got this one with four terms, this one with four terms, this one only has three, and this one only has two. So again, we're only looking at a and b at this point. And we're subtracting, so it's going to be positive, negative, positive, negative. So which one goes positive, negative, positive, negative? And it's going to be this one. Positive, negative, positive, negative goes in the right order. X cubed, x squared y, xy squared, y cubed. Okay, directions. Drag each label to the correct location on the image. Make sure I can see this a little better. Each label can be used more than once, but not all labels will be used. Complete Pascal's triangle and also complete the missing coefficients of the binomial. So Pascal's triangle, again, we're just adding the two that kind of are right above it to get that number. So 1 and 2, what's 1 plus 2? 3. And again, what's 1 plus 2? 3. Okay, 2 plus 1 right there. And then what's 3 plus 3? 6. So 6 goes right there. And then what is 4 plus 6? 10. So 10 goes right there. We also need this over here. All the way down the sides are just ones. You have to imagine it's like 1 plus nothing since there's no number right here. 1 plus 0 is 1. So it just keeps being ones all the way down. And now that we have Pascal's triangle filled out, we can do that. X plus y to the fourth power is going to be not this top one, but 1, 2, 3, 4 below that, the one with 5 terms in it. So 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. So I'm putting my 6 right there and the 1 right there. Expand the following expression, 7x plus 3y squared. Okay, it's all positive. Which ones have 3 terms? This one, and this one. So it's either A, C, or D. B does not qualify. It does not have 3 terms in it. First things first, it's only squared. So we're just going to have 7x times 7x in the beginning, which is 49x squared. So which ones start with 49x squared? You're looking at A and C. And hopefully they both end with 3y times 3y, which is 9y squared. And they do, 9y squared and 9y squared. So what is the middle term? Is the middle term 21xy or 42xy? 21 or 42. Well, if you go back to our previous problem where we did a plus b squared, you remember it was a squared plus 2ab plus b squared. So the first term gets squared, the last term gets squared, and the middle is just the first term times the second term times 2. In this case, our terms are 7x plus 3y. So we've already squared our first term. We got 49x squared. We already squared our last term. 3y times 3y is 9y squared. And now we just have to do the middle part of it, which is the first term times the second, a times b, then times 2. So I get 7 times 3 is 21, and 21 times 2 is 42. So I get 42xy. Expand the following expression using Pascal's triangle, x plus y to the 6th power. So we go ahead and look at Pascal's triangle. It's right here. We're going to use where n equals 6. That's n is the exponent that we're using. It should be the 7th row, or there should be 7 terms. 1, 2, 3, 4, 5, 6, 7. There it is. So I have 1, 6, 15, 20, 15, 6, 1. 1, 6, 15, 20, 15, 6, and 1. So which one has that pattern? It's going to have 7 terms. That one only has 2. That's not it. 1, 2, 3, 4, 5. That one only has 5 terms. 1, 2, 3, 4, 5, 6. That one only has 6 terms. 1, 2, 3, 4, 5, 6, 7. This is the only one with 7 terms. It's the only one going to work. And of course, if you look at the coefficients, they follow Pascal's triangle. 1, 6, 15, 20, 15, 6, and 1. 1, x to the 6th. 6, 15, 20, 15, 6, and 1. 6x plus 4y to the 4th power. If we expand that, the first thing is going to be 6x to the 4th power. The last one's going to be 4y to the 4th power. There's 4 as an exponent, so there's going to be 5 terms. So let's start looking at that. Where's 5 terms? 1, 2, 3, 4, 5. This one, 1, 2, 3, 4, 5. This one, 1, 2, 3, 4, 5. This one only has 2. So we're looking at A, C, and D. Next, we're adding. So there should only be positive values in here. A has all positive values. C has all positive values. D has some subtraction in there. Not going to show up if your binomial is 2 things being added together raised to an exponent. No negatives are going to pop up. So now we already know it's either A or C. And the very first thing is they have completely different terms right off the bat. So all we have to do is figure out what is 6x to the 4th power, and we will figure that out. So we've got 6 to the 4th power. You can do any calculator with this. 6 to the 4th power is 1,296. So when you look at your problem, you're going to have 1,296x to the 4th power as your starting point. This has got a whole bunch of extra stuff. That's not what we want. Next one, expand the following expression. We have 3x minus 4y to the 5th power. So to the 5th power, we should have 6 terms. Which one of these has 6 terms? A has 1, 2, 3, 4, 5 terms. B has 1, 2, 3, 4, 5, 6 terms. So maybe it's B. C has 1, 2, 3, 4, 5, 6 terms. So maybe it's C. D only has 4 terms. So we know it's going to be B or C. Again, the number of terms in the expanded polynomial is going to be 1 more than whatever that exponent is. So if it's B or C, that's what we're looking at. Well, it is subtraction. So do they both follow the pattern? Positive, negative, positive, negative, positive, negative. Let's check. Positive, negative, positive, negative, positive, negative. So yes, they both follow that pattern. So let's find the difference that they have. They both have 243x to the fifth. They both say minus 1,620 x to the fourth times y. Then they both say plus 4,320 x to the third y squared. Then they both say minus 5,760 x squared y cubed. Then they both say, well, they both say 3,840, but what's this say? X squared y to the fourth? What? No, x y to the fourth. We already had our x squared. We have to subtract every single time from the previous exponent. So x to the fifth, x to the fourth, x to the third, x squared, x to the first. It should not be x squared again. So B is our answer. And last but not least, expand the following expression, negative 4x minus 1/2 y to the fourth power. Again, it's going to have 5 terms. Which one of these has 5 terms? 1, 2, 3, 4, 5. This one, 1, 2, 3, 4, 5. These do not. So it's going to be A or B. Which one of these in the beginning is negative 4x to the fourth power? Negative 4x to the fourth power. Negative 4x to the fourth power. So negative 4 to the fourth power is going to be which one of these? Well, it's sure as heck is not going to be 4x to the fourth. Negative 4 to the fourth power is 256. When you multiply something by an even exponent, it's going to be a positive. So if you have a negative 4 to the fourth power, it's going to be a negative times a negative times a negative times a negative, which is going to end up being a positive. In the other ones, that could change some things up. So notice that we're subtracting here, but we've got all these positive answers because the fourth power makes everything positive when you're multiplying that by it. So that's going to change up some things when you have a difference in your binomial. Right, now there were no questions in that particular session that asked you to find a specific term. So I'm going to pause this. I'm going to search for one of those questions and I'll come back and I'll show you. Okay, so here's another type of problem you might run into. Use Pascal's triangle to expand the expression above. Determine which of the following terms appear in the expanded form of the binomial. So we have x plus y to the fifth power. If we go to Pascal's triangle, that's this row with 6 terms in it, where n equals 5. So if I want to expand that, x plus y to the fifth power, which one of these is going to be in there? Well, I'm going to have x to the fifth power, 1x to the fifth power, then 5, x, let me just write this down so you can see it. I'm starting with x plus y to the fifth power, and the numbers in that row of Pascal's triangle are 1, 5, 10, 10, 5, 1. So these are 1, 5, 10, 10, 5, 1. So here we go. 1, x to the fifth, y to the 0. So I don't even need to consider y. It's just going to be 1 x to the fifth. And then plus 5, and now I put x to the fourth times y, and then plus 10, x to the third, y squared. I'm just writing x and y, and I'm subtracting from the exponent on the x and adding to the exponent on the y each time. And then plus 10, x squared, y cubed. And then I've got, after that, plus 5xy to the fourth, and then plus y to the fifth. So that is my expanded expression right there. So which one of these problems, determine which of the following terms appear in the expanded form. So let's go through. Is 10x cubed y squared in there? Absolutely. 10x cubed y squared. Is 10x cubed y in there? No, absolutely not. Is 5x to the fifth in there? No, it's just 1x to the fifth. We don't need that. Y to the fifth? Absolutely. 1y to the fifth. 5xy to the fourth. That's right down there. 5xy to the fourth. And 6x fourth to the y. No, absolutely not. So those 3 terms appear and those other 3 do not. Again, let me look for a specific problem that you'll need. Okay, so I finally found a problem that you might run into that I want to show you how to do. So here we go. What is the 7th term of that binomial? That binomial is x to the 9th plus y squared, all raised to the 12th power. And I don't need the whole expanded thing or anything like that. I just want to know the 7th term. Well, if you go to your study on lesson, there's an example. Here's a formula here. Now, this looks kind of intimidating and crazy, but it's really not if you just break it down one step at a time. And so let's go ahead and do that. First of all, it says the rth term. We want to know the 7th term. So when we look at this formula, the r that we're going to use, r equals 7 in our case. Okay. After that, we have two terms being raised to an exponent n. In this problem, the exponent that the two things are being raised to is 12. So again, in our problem, n equals 12. And then each thing inside, it just says x, and this just says y. Well, our x happens to be x to the 9th power, and our y happens to be y to the 2nd power. So we're going to have to remember that when we're looking at this formula, that our x is actually x to the 12th, and our y is actually y squared. So all we have to do is plug these numbers into this formula. Now, what exactly does this formula say? It says if you want the rth terms, or in our case, the 7th term of something like that raised to an exponent, you're going to make a fraction. Now, it's a big fraction. What's on the top here? What's with the dots? Well, it's a pattern that has an endpoint. First, you're going to start with n. So we're going to start with Rn, which is 12. And we're going to multiply that by n minus 1. Well, if Rn is 12, 12 minus 1 is 11. And then n minus 2. Well, for us, that'd be 10. And you're going to keep doing that until you end at whatever this is. And this says n minus r plus 2. Or for us, 12 minus 7 plus 2. So 12 minus 7 is 5. And 5 plus 2 is 7. So we're going to end this. We're going to end this sequence when we finally get to 12 minus 7 plus 2, which is 7. 12 minus 7 is 5, and 5 plus 2 is 7. So we're doing 12 times 11 times 10 times 9 times 8 times 7. So you follow the pattern all the way until you get to that last term, which is your exponent on the binomial, which in this case is 12, minus whatever term they're asking you for, which in this case is 7 because they're asking for the 7th term. And then you add 2 to that. And you're going to divide that by the bottom. Now, the bottom says r minus 1 factorial. So don't forget our r is 7. So it's going to be 7 minus 1, which is 6. So 6 factorial. And don't forget what 6 factorial means. 6 factorial means 6 times 5 times 4 times 3 times 2 times 1. So we're dividing those two things. And then we're going to multiply that by x, which in our case, remember, is actually x to the 12th power. A little bit more room here. Our x is actually x to the 12th power. Raise that to n minus r plus 1. So let's go ahead and just write that out for a moment. I'm going to figure out what this whole fraction is in a second, okay? But we're going to do that, and then our x to the 9th power, what was it? Yeah, x to the 9th power. I don't know why I wrote x to the 12th power here. I screwed that up. Excuse me. X to the 9th power. If you caught that earlier, good. If not, I apologize. Our x is x to the 9th power. I had 12 on the brain, so I apologize for that mistake. So it's going to be x to the 9th power, but we're going to raise that to another exponent, and that exponent is n minus r plus 1. Again, our n is 12. Our r is 7. So 12 minus 7 is 5, and then plus 1 is 6. So to the 6th power, and then that's going to be times y, which in our case is y squared, raised to r minus 1. Again, our r is 7. 7 minus 1 is 6. So what do these come out to be? Well, x to the 9th to the 6th is x to the 54th power, and y squared to the 6th is y to the 12th power. So now all I have to do is figure out what this is, and it's going to be times x to the 54th and y to the 12th power. We can already start eliminating things because we only have 2 here that are x to the 54th and y to the 12th, and all you have to do at this point is figure out what those are. So you plug that into a calculator, and you'll get your answer. I'm going to go ahead and plug it in. I can use Google, I believe, for this. It's not have a calculator handy. I'll start with parentheses here, and I'll say 12 times 11 times 10 times 9 times 9 times 8 times 7 divided by 6 factorial. Let's see what that says. 924. It says it right there. So again, 12 times 11 times 10 times 9 times 8 times 7 divided by 6 factorial is 924. And voila, 924, x to the 54th, y to the 12th. So again, if you need to see it, it's right here. You don't have to remember this, memorize it, or anything like that. If you use it enough times, you will. But that's what's going on here. You just take your R is the whatever term they're asking for. So in that last case, it was asking for the seventh term. Your N is what it's being raised to. And then you have your X and your Y. Let's go ahead and take a look at the example problem just to make sure that we're on board with that, since we only saw one of those problems and I don't know when another one's going to pop up. This one asks for the sixth term of this binomial. So R is going to be 6, so it's the sixth term. The binomial is 2x plus y, and n in this case, the thing it's being raised to, is 9. So it starts off with 9, then times 9 minus 1, times 9 minus 2, times 9 minus 3, and then times 9 minus 4. Why 9 minus 4? Why does it stop there? Because it's 9 minus 6 plus 2, which is the same as 9 minus 4. And you're dividing that by 6 minus 1, because it's asking for 6, and it's r minus 1. 6 minus 1 is 5. So it has that, and then what's their x? Their first term is 2x. So it's 2x to that, and then their y to that. It's the exact same pattern that we just followed. And then 9 times 8 times 7 times 6 times 5 divided by 5 factorial. Plug that into a calculator, you get 126. 2x to the fourth power is 16x to the fourth. Y to the fifth is just y to the fifth, and you get your answer right there. Hopefully this is enough. Let me know if you have any other specific questions or any problems that trip you up. This stuff, if you read through it, this is not at all confusing if you understand the choose formula. If you understand the choose formula, then you understand how to read this. Every problem that I did for you, I gave you a process of elimination way of doing it because it gave you multiple choice. And I wanted you to understand the basic tenets of this, of the binomial theorem. But if you're not given multiple choice, you're going to have to plug in all of this stuff to figure out. So if you understand the choose formula, if you can read this, if you understand what it means, take your time, plug it in one step at a time. If you're trying to do that and don't know how, let me know and I can help you with that. But it's really important that you understand the choose formula and able to understand that those, if you're able to understand the choose formula, that's how you're able to understand all of this stuff. So let me know if you need help figuring that out, but go do that particular topic first. That's it. Have a great